Namaste students. Today we are going to start with the next topic of class 11, that is permutation and combinations. Permutation and combinations. Very important and you can say interesting topic, and very useful in our day-to-day lives. Very useful in our day-to-day life. For example, you go to an ATM, alright, and you know that ATM, when we put a pin, enter the pin, it's a 4-digit number. Alright, so 4-digit number it is, and you by chance forget, and you know that my number starts with 6, that I know, but now I know my number starts with 6, but there are 3 more blanks. Now these 3 more blanks I don't remember now, so that means these 3 blanks can have any number between 0 to 9. These 3 blanks can have any number between 0 to 9. So if I start thinking, अच्छा 6 के साथ क्या हो सकता है? 0, 1, 2, 0, 2, 3, 0, 5, 6, 0, 1, 6. So it is very difficult to think about it. It is very time consuming. Is it clear? So can you do that? We can't do that. If I start thinking in an ATM machine and keep standing how many such kind of numbers will be possible, where first number starts with 6 and I have 3 more blanks which can be filled from any number out of 0 to 9, maybe with repetition, without repetition, and so on. Fine. So it is, time consuming. So I can't sit and make such kind of arrangements manually. So for that we need a method. For that we need a method, or we need a principle by which I can solve such kind of practical problems. I can solve such kind of practical problems. Here there are 10 children, they have to be seated on the bench. In how many ways they can be seated? Alright, there's a conference going on, there's a round table, people have to sit there. How this arrangement is possible? There are 20 people, I have to make a class representative, how to choose 2 children out of those 20. Such kind of problems when you face, there's a method that is called principle of counting. Principle of counting, or we say principle of association of events. Principle of association of events. Principle of association of events. Alright, fine. And children, one more thing. This chapter is going to play very important role in your probability also. Alright, principle of counting, or we call it principle of association of event. This I'll explain you with an example. For example, you go to a park. Alright, you go to a park. When you enter, there are 3 entrance gates. You can enter by gate 1, you can enter by gate 2, you can enter by gate 3. There are 3 entrances when you go to the park. Alright, there are 3 gates from where you can enter, but when you exit, there are only 2 gates. When you exit, there are only 2 gates. That means there are outlets, are outlet 1 and outlet 2. Outlet 1 and outlet 2. Now my question is, in how many ways I can enter and exit from the park? In how many ways I can enter and exit from the park? Is it clear? So, what are the possibilities? The ways or the possibilities now that can be, I enter by gate 1 and exit by gate 1. That means this is possible. Alright, I enter by gate 1 but exit by the second one. That is possible. With gate 1, I have 2 options of exiting. O1 and O2. So E1, O1 is my one way, E1, O2 is my one way. Same way, suppose if I enter by second gate, exit by this or exit by this, that means I enter by second gate and exit by first, I enter by second gate or exit by second. Clear? That's my option. Or I choose to go by the third gate. Then I enter with the third gate but exit with the first gate, enter with this and exit with this. That means enter by third gate, out by gate 1, enter by gate 3, out by the outlet 2. So that means when I have to go to the park, I have to enter and I have exit. I have total 1, 2, 3, 4, 5, 6. I have total 6 ways of doing that. See how it's a practical problem, no? Such an easy thing. Alright, so I have 6 ways of doing it. But there's a problem. Right now it was only 3 and there were 2 exits. Suppose there are 10 entrances. You go to some, say, mall. There are 10 entrances and there are different lifts to come down. Alright, then practically if you start making this way, it will be very time consuming. So I can't go with this method of listing everything manually. So that means I have to come to this principle of counting. So let's write what this principle of counting is. But from this example only we are going to write the definition. See, it has come 6. How many gates were there for entrance? 3. How many gates were there for exit? 2. So 3 into 2 what? 6. So nothing, the definition is not going to be something different. It's going to be from this definition only. That means if first event, you remember we have already done probability in class 10. Event means happening of something. Is it the event? My first event is to enter the park. So that thing I can do in 3 ways. Either I can go by gate 1, gate 2, gate 3. Fine. So my first event, my first task of entering in the park is done in 3 ways. Clear? That's 3. Followed by, I have to exit the park. I have to move out of the park. Clear? And my exit, that means my next task is to come out of the park. That can be done in 2 ways. First event can be performed in 3 ways, followed by the second event, which can be done in 2 different ways. First in 3 different ways, the first task, and second in 2 different ways. So that means the total number of ways in which I can do it, that means the first into the second. Number of ways, the different ways in which the first task can be performed, into number of ways in which the second task can be performed. Is it clear? So let's write the definition from this example. Let's see the definition. See, what is the definition? You remember the example now, what we have done? That means when I was entering in the park, I had 3 gates. When I had to exit from the park, I had 2 ways. So, number of ways of the first event, number of different ways in which the first event can occur, into the number of different ways in which the second event can occur, will be the giving you the total number of ways in which that task can be performed, which is given to you. Alright, so the definition is also the same. If an event A can occur in m different ways, alright, if an event A, that means the first task can be performed in m different ways, and following which the another event B can be performed in n different ways. Alright, the first task can be performed in n different ways and the second task can be performed in n different ways. Then the total number of occurrence of both the events A and B is given by m into n. It's exactly the same what we did in the example. I can enter in the park in 3 ways, multiplied by I can exit from the park in 2 ways. So the first task can perform in m different ways, the second task can be performed in n different ways, and the total number in which A and B can be performed It's taken in the order, that will be m into n. Alright, clear children? So one thing, first task in how many different ways, second task in how many different ways, and then multiply. And one more thing, this is not applicable only for 2 tasks. It can be applicable for number of tasks. Alright, like the first task can be performed. Let A, B, C are the events which can be performed in M. A can be performed in n different ways, followed by B in n different ways, followed by C. एक एक करके होना ये इवेंट, ऐसे नहीं इकट्ठा सब कुछ हो जाएगा. No. First A is performed task. First I will enter in the park, then only I will exit. No. So that means the first A can be performed in m different ways, B can be performed in n different ways, followed by C can be performed in P different ways. So then the total number of occurrence of all these 3 events, total number of occurrence of these 3 events is going to be m into n into p. M into n into p. If there are 4 events, so m into n into p into q, that's it. Is it clear? Very easy, the principle of counting. First task is performed in m different way, followed by the second task is performed in n different ways, followed by the third task is performed in p different ways. So that means the total number of ways in which this task, total combined task can be performed, that will be m into n into p. Is it clear? Right now we are doing for principle of counting. We have not touched our topic permutation and combination. That is later on. Understood, children? Is it clear? Now we will support this with example so that the concept of principle of counting becomes more clear to you all. Okay, let's see the examples. The first one, before that, when we are saying the principle of counting, principle of association of events, if you have seen in principle of counting, we are multiplying, no? The first event can be performed in m different ways, followed by the second event can be performed in n different ways. So the total number of possibilities of occurrence of these events would be m into n. So sometimes we call it, sometimes we can write it as principle of multiplication also. Is it clear? So don't get like, see, what is this principle of multiplication? This principle of counting can be called principle of multiplication also. Now look at the first question, read the first question. Find the number of 4-letter words with or without meaning which can be formed out of the letters of the word rose where the repetition of the letters is not allowed. What is given to me? What is given to me? There is a one letter given to me, that is rose. The word is given rose. Alright. Out of this I have to form a 4-letter word. I have to form the 4-letter words. That means I have to fill this 4 blanks. I have to form 4-letter words such that this is repetition of the letters is not allowed. Repetition of the letters is not allowed. Clear? So I have to form 4-letter words using these letters only where the repetition is not allowed. Suppose R, if I have used at one place, so R cannot be repeated. So I have to use the another letter. Clear? So see, easiest way is, first of all, make these blanks, fill it, then you write the theory part. Alright, questions are very easy. You just have to think a little, that's it. Alright. So that means if I think about the first blank, this for first blank, how many options I have? I can pick up R, I can pick up O, I can pick up S, I can pick up E. So that means my first blank can be filled in 4 ways. 4 different ways. Clear? Alright. Now, one out of these 4 letters have been chosen. So now repetition is not allowed. This is repetition of the letters is not allowed. Clear? So that means that whatever I have written here, I won't be repeating it. So that means how many choices are left for my second blank? 3 ways. I have only 3 choices. 3 ways I can fill the second blank. Now, one letter is filled here, second letter is filled here. Now for the third blank, how many letters are left with me? I am left with 2 ways only. Left with 2 ways. Is it clear? Alright. And 3 letters are already filled. Repetition is not allowed. So first is 1 way. Clear? So that means by principle of multiplication, we know that if it is one event followed by other in different ways, followed by other, we just have to multiply it. So by principle of multiplication, total number of words without repetition are 4 into 3 into 2 into 1. So there will be 24 words are possible with or without meaning using the letters of the word rose where the repetition is not allowed. I hope it's clear to everyone. So the easiest way is you make the blanks. Try to fill the blanks according to the given condition, whether repetition is there or not repetition. For example, had it been in this question repetition is there. ठीक है, अगर इसके अंदर होता कि repetition है, I have to fill these 4 blanks. And they say the repetition of the letters is allowed. So that means if I fill this in 4 ways, I can fill this in 4 ways. Alright, clear? So that means this can be filled in 4 ways. Repetition is allowed. So if I put R here, so I can put any letter here also, the same letter. So this also can be done in 4 ways. This also can be done in 4 ways. This also can be done in 4 ways. That means the number of words possible will be 4 into 4 into 4 into 4. That will be 4 raised to power 4. Is it clear? When the repetition is allowed, they said you can repeat. So that's your choice. You can fill the first blank with 4 ways. Second also, now whatever is filled here, you can fill it again. So I have 4 open choices for the second blank. I have 4 open choices for the third blank. I have 4 open choices for the first blank. So that means the number of letters which can be framed when the repetition is allowed, it will be 4 raised to power 4. Is it clear? 4 raised to power 4. I hope it's clear to everyone. Clear? So again, the questions are very easy. The only thing is that you just have to think. Make it easy. Now read the next one. Given 4 flags of different colors. You have total 4 flags of different colors. How many different signals can be generated if a signal requires the use of 2 flags, one below the other? I have to give signals to suppose some war is going on, something is going on. I have to give the signal to my partners. I have to give a signal to my soldiers. So I need 2. I have told them I will be using 2 flags. Clear? Now this is in how many. If signal required 2 flags, one below the other, given 4 flags of different, how many different signals can be generated? How many flags do I have of different colors? I have 4 flags in total. But I have to use how many flags? I have to use only 2 flags. That means I have 2 blanks to fill. I have 2 blanks to fill. And he says how many different signals can be generated, different signals. When I say different signals, suppose I have 4 flags of different colors. Suppose I have a red, green, yellow, blue. So I can't use both red. That's 2, both the flags are going to be same. I can't use both greens. Is it clear? Different signal means I have to choose a flag of different colors. Now coming to the first blank. The first flag. How many options does the first flag have? I have 4 flags. Red, blue, yellow, green. Is it clear? So the first flag can be any one out of those 4. So that means the first flag can be chosen in 4 ways. The first flag can be chosen in 4 ways. Is it clear? Now first one flag has already been chosen. Suppose red color I have already chosen. So the second flag which I have to pick up, I have to pick up from remaining 3 because I have to generate the different signals. So that means how many ways? Clear? So by principle of multiplication, total number of different signals generated what? 4 into 3, 12. I can generate 12 different signals. Alright, out of the 4 flags, taken 2 at a time. Taken 2 at a time. Clear to everyone? Alright, fine. So this is how you are going to do the questions. Let's see the next one. How many 2-digit even number can be formed? You have to be careful what is written there. It is 2-digit. That means I have to fill 2 places. I have to form 2-digit number, 1's place and 10's place. Clear? 2-digit even numbers can be formed from the digits using 1, 2, 3, 4, 5. I have 5 choices of the numbers if the digits can be repeated. If the digits can be repeated. Digits repeat हो सकते हैं. लेकिन सबसे पहले what is given to me? 2-digit number होने चाहिए, but वो कौन से होने चाहिए? Even number होने चाहिए. 2-digit even number. Alright? So even numbers क्या होते हैं? जिसके unit place पे क्या होता है? 0, 2, 4, 6, 8. You know that? Clear? So that means I have a restriction for unit place. I have a restriction for unit place. To make it even, it has to be filled by an even number. And from the given list of numbers, I have only 2 even numbers. Those are 2 and 4. That means for the unit place, I have only 2 options. 2 ways, those are either 2 or 4. Either 2 or 4. So 2 ways the unit place can be filled. Clear? Now coming to 10's place. He says digits will repeat. Whatever you have picked up here, for the even number, there is no restriction for 10's place. Only unit place is a restriction. Fine. So whatever you have to fill in the 10's place, how many options? Whatever you have filled here, that can be repeated. So all 5 numbers can come because this is repeated. अगर non-repeated होता तो जो यहाँ आ गया वो नहीं होता. तो total 5 में से एक यहाँ आ गया तो यहाँ के लिए 4 बचते. लेकिन अब क्या है? 1 is come here, but he says the number can be repeated. So this place can be filled, 10's place can be filled in 5 different ways. 10's place can be filled in 5 different ways. So total number of 2-digit even numbers will be 5 into 2, that will be 10. 2-digit even number out of the given numbers are 10. Is it clear to everyone? So you have to be very careful, children, what is given to you. What condition is given to you? They told 2-digit even number. So when it is an even number, so you have to be careful choosing the unit place. Clear? And then they say the digits can be repeated. So 10's place can be filled by any number which is given to me. So 5. So 5 into 2. 10 even numbers are possible out of it. Let's see the next example. In how many ways 5 persons sit in a car so that 2 persons including driver sit in the front seat and 3 persons sit in the back seat? If 2 particular persons out of 5 cannot drive. Is it clear? What is given to me? There's a car and there are 5 seats. 5 persons have to sit. In the front, one would be the driver's seat, one would be the other one. Suppose I have 5 seats to be 1, 2, 3, 4, 5. This is the driver's seat. Clear? Rest, other seats are there. In front 2 will sit. Definitely one driver has to sit and the remaining 3 would be sitting at the back seat. Now I have to fill these 5 seats. I need to see how many ways I can fill these 5 seats. Now first of all, let's pick up the driver because that's important. The car will move when there's a driver. Now there's a restriction given for the driver. So that's why I told you children, very careful while reading the question. He says if 2 particular persons out of 5 cannot drive. There are 5 people going to the office. But out of these 5, 2 cannot drive. So that means for the driver's seat, I have only how many options? I have only 3 options. Driver's seat can be filled only in 3 ways. Driver's seat can be filled only in 3 ways. Is it clear? So for driver, there are only 3 options. Now out of those 3, those who could drive, one is already settled here as a driver. He is sitting on the driver's seat. Now I am left with 4 seats and 4 persons. So absolutely fine. Now the second, who's maybe the side seat of the front seat of with the driver, that all 4 have options. They can sit in 4 ways. अब एक और adjust हो गया आगे. So इसके लिए how many persons are left? This can be filled in 2-3 ways. The second seat can be filled in this ways, and one last seat के लिए एक ही person बचेगा. I hope it's clear. First of all, the choices of a driver, because driver पर restriction दे रखी है कि पांचों के पांचों ड्राइव नहीं कर सकते हैं. 5 में से 2 बिल्कुल ड्राइव नहीं कर सकते, सिर्फ 3 ड्राइव कर सकते हैं. तो 3 ड्राइव कर सकते हैं, तो ड्राइवर सीट के लिए मेरे पास सिर्फ 3 ऑप्शन है. जो ड्राइव कर सकते हैं उसमें से ही चूज करना है. अब एक ड्राइवर फिक्स हो गया. अब फ्रंट सीट के लिए कितने ऑप्शंस? चारों में से कोई भी बैठ सकता है. अब बैक की 3 सीट्स हैं. एक सीट पे एनी पर्सन कैन सिट. सेकंड पे 2 पर्संस हैव अ चॉइस, एंड द लास्ट सीट अब सब बैठ चुके हैं तो उस पर्सन को लास्ट सीट पे बैठना पड़ेगा. सो टोटल नंबर ऑफ वेज दिस कैन बी डन, दैट इज 3 into 4 into 3 into 2 into 1. Alright, so there are 72 ways in which such kind of arrangements can be made. So, can you imagine? This is such an interesting question. You know, you are going for a picnic with your parents. It's a 5-seater car. Alright, and you have to see कि हम लोग कितने वे में बैठ सकते हैं. How quick it is now. Otherwise, so you arrange one only. अच्छा ऐसे ही बैठ सकते हैं. But I have 72 ways in which these 5 people can be arranged, and that also with restriction. That also with restriction. Is it clear to everyone? So this is how we solve. Coming to the next one. Given 5 flags in different colors, how many different signals can be generated by arranging at least 2 flags in order, one below the other, on a vertical staff? Now earlier we did the same kind of question. There was only signal had to be generated by using 2 flags. अब इसने बोला at least 2. At least का क्या मतलब होता है? Probability में, permutation combination में at least, at most बहुत important role play करते हैं बच्चों. Clear? So when I say at least, इसका मतलब 2 flags से भी generate हो सकता है signal, 3 flags को भी use करके generate हो सकता है signal, 4 flags को use करके भी signal generate हो सकता है, and 5 flags all together को use करके भी signal generate हो सकता है. तो सबसे पहले अब इसमें cases बनेंगे. Using 2 flags. 2 flags का earlier we did it. One below the other. 5 ways and 4 ways. Different है. So total will be 5 into 4, that will be 20. Case 2. Using 3 flags. So I have 1 flag, second flag, third flag. 5 ways, 4 ways, 3 ways. So it will be 5 into 4 into 3. By now you know it how to do it. Alright, case 3. Using 4 flags. One below the other. 1, 2, 3, 4. 5 flags, all 5. It has 4 options, it has 3 options, it has 2 options. So 5 into 4 into 3 into 2. It will be 120. Clear? Using all 5 together. Case 4, all 5 flags. Alright, all 5 flags. So 1, 2, 3, 4, 5. So first flag has 5 options, 5 different colors. Second has 4, third has 3, 2, 1. So total number of signals can be generated by using 5 flags altogether would be 5 into 4 into 2. So that's 120. Is it clear? Very clear? So I can use either 2 flags, or I can use 3 flags, or I can use 4 flags, or I can use 5 flags altogether. So that means ये भी option है, ये भी option है, ये भी option, or means what? Plus with it, or either this or this or this or this. That means that is plus. So total number of signals can be generated. Signals can be generated will be 20 plus 60 plus 120 plus 120. Is it clear? So that means total 320 such signals can be generated by using these flags. I hope it's clear to everyone. Alright. Fine. So that means when you read the questions are very easy. You just have to be little careful how to go about it. Let's pick up the last example of this topic. How many numbers are there between 100 and 1000 which have exactly one of its digits at 7? Exactly one of its digits has 7. First of all, between 100 and 1000, what we will have? 3-digit numbers. We have to frame 3-digit numbers. Now those 3-digit numbers, that means 1, 2, 3 blanks I have to fill. One is unit place, ones place, tens place and hundreds place I have to fill. Clear? Now it says इन तीनों में से एक नंबर 7 होना चाहिए. That is compulsory. जो 3 नंबर फिल किए जाएंगे उसमें से 7 यहाँ भी हो सकता है, 7 यहाँ भी हो सकता है, 7 यहाँ भी हो सकता है, but होना चाहिए. So that means when I have 7 either in the unit place, ones place or hundreds place, unit place, tens place and the hundred place, so I have to do the cases. Case 1, when 7 is at units place. That means 1, 2 and 3 has to be filled. So now 7 is fixed on the unit place. So that means I have only one way. I have only one way. Is it clear? I have only one way of filling it. Clear? First of all, what is the choice? How many numbers do I have? 3-digit numbers I have to frame. So no restriction is given to me. That means how many choices I have? I can fill, the numbers are between 0 to 9. Definitely 0 से 9 के बीच में कोई भी नंबर ले सकते हैं हम लोग. Clear? So but 7 is on the unit place, so 0 से 9 के बीच में 7 तो यहीं आएगा. So unit place has a fixed value, that is 7. अब coming to this, coming to the next one. All right. Now one number 7 is already filled here. और क्या लिखा है यहाँ पर? Which have exactly one of its digits as 7. एक ही बार आना चाहिए 7. अब यहाँ कुछ नहीं लिखा, रिपीटेशन नॉट रिपीटेशन ऐसे नहीं लिखा. 7 एक बार आना चाहिए. इसका मतलब 7 अगर यहाँ आ गया तो 7 यहाँ नहीं आ सकता, 7 यहाँ नहीं आ सकता. ठीक है, 7 यहाँ आ गया. इसका मतलब इस टेंस प्लेस के लिए मेरे पास कितनी चॉइसेस हैं? 0 से 9 हाउ मेनी नंबर्स आई हैव? आई हैव 10 नंबर्स इन टोटल. उसमें से एक नंबर चला गया 7. तो कितनी चॉइसेस बची टेंस प्लेस के लिए? आई हैव 9 चॉइसेस. समझ आया? आई हैव 9 चॉइसेस बिकॉज 7 यहाँ फिल हो चुका है. 0 से 9 में 7 हटाया, कितने नंबर बचे? 9. बिकॉज 0 से 9 में टोटल नंबर कितने होते हैं? 10 होते हैं. 0 1 2 3 4 5 6 7 8 9 10. So I have 9 ways of filling it here. Now coming to hundreds place, it should be 3-digit numbers. Clear? अब तो 7 यहाँ आया तो इसके लिए ऐसा कोई रिस्ट्रिक्शन नहीं है, कोई भी 9 नंबर आ सकते हैं. लेकिन एक प्रॉब्लम, 0 से 9 में 7 को छोड़कर आई हैव 9 नंबर्स. तो इसका मतलब इसमें 9 चॉइसेस हो सकती हैं. बट देयर इज अ प्रॉब्लम. सो दैट्स व्हाई आई सेड यू हैव टू बी वेरी केयरफुल. टॉपिक इज इजी बट यू नीड टू थिंक. फर्स्ट प्लेस पे अगर 0 आ गया तो क्या हो जाएगा? ये तो 2-digit नंबर बन जाएगा. तो नंबर तो 100 और 1000 के बीच में 3-digit नंबर्स होने चाहिए. इसका मतलब अगेन देयर इज अ रिस्ट्रिक्शन कि 0 यहाँ नहीं आ सकता. दिस प्लेस कैन नॉट बी फिल्ड विद 0. इज इट क्लियर? दिस प्लेस कैन नॉट बी फिल्ड विद 0. इसका मतलब 7 को छोड़कर 9 नंबर्स में, पर 9 नंबर्स में से भी 0 यहाँ नहीं आ सकता. इसका मतलब दिस कैन बी फिल्ड इन 8 ways. So total number कितना हो गया? 8 into 9 into 1, that would be 72. Is this clear? I hope it's very clear to you. So without thinking, don't jump on the conclusion कि अच्छा फर्स्ट प्लेस है, चलो 7 नहीं फिल करना, कोई ये नहीं लिखा हुआ कि रिपीटेशन नहीं होनी है तो 0 से 9 9 कर दो. नो, फर्स्ट नंबर कैन नॉट बी 0. अगर ये 0 बन गया तो 2-digit नंबर बन जाएगा. 2-digit नंबर बन गया तो 100 और 1000 के बीच में नहीं आएगा. क्लियर? सो यू नीड टू थिंक वाइजली. केस 2, 7 at 10th place. 1 2 3 10th place फिक्स हो गई. 1 way, सिर्फ यहाँ 7 आएगा और कुछ नहीं आएगा. क्लियर? नाउ फॉर दिस 0 से 9 में 7 चला गया तो इट हैज 9 ways. इस पे भी सारी 9 चॉइसेस हो सकती थी बिकॉज ये फर्स्ट नंबर है, 0 नहीं हो सकता तो इट हैज टू बी 8 ways. So total 8 into 1 into 9, that is 72. Clear? All right. Case 3. 7 at hundreds place. that means 1, 2 and 3. So that means the 100 place, the first number has to be 7. The first number has to be 7. So one way. अब फर्स्ट ही प्लेस कवर हो गई, अब जीरो वाले को टेंशन नहीं है, कहाँ मर्जी आ जाए. Is it clear? First place is filled by 7. So that means the next place other than 7 I have all open choices 9. Because उसने कुछ नहीं बोला कि रिपीटिशन है या नहीं है. So इसके 9 है तो इसके भी 9. अब जीरो वाली रिस्ट्रिक्शन नहीं है. जीरो की रिस्ट्रिक्शन हमेशा वहां आती है where we are talking about the first number, the first place. Is it clear? Alright. So how many ways? So that means this is also possible, this is also possible, this is also possible. So total number possible are, total numbers will be is it clear? All right. So 225 such numbers are possible. So you have to be very careful. Though I told you the topic is easy, but when it is easy, you have to be more careful. You know, it's easy, but you have to think. ऐसा नहीं सोचते फटाफट कंक्लूजन पे जंप करो और सोचो ही नहीं कि जीरो भी आ रहा है वहां पर, और बच्चे यही गलती करते हैं. Clear girls, children? So what you have to do it, you have to think about the question properly. क्या रिस्ट्रिक्शन है इस क्वेश्चन की, लिखी है या नहीं लिखी है, तुमने अपना दिमाग लगाना है. And then you will be able to solve such kind of questions.